Okay, today we're going to talk about finding zeros. The zero of a function is the x-intercept. It's the value of x that results in y being 0, or our function equaling 0. We're going to look at two different ways to find zeros, both graphically and algebraically. Example 1, f of x equals 3x minus 12. Hopefully you can see that this is a linear function. We only have x to the 1 power, which means it will form a straight line. We're going to first find the zero graphically, and we're going to make a graph of 3x minus 12. It has a y-intercept at negative 12 and a slope of up 3 over 1, up 3 over 1, up 3 over 1, etc. Graphically, we can see right here the place where our function crosses the x-axis, which is called the x-intercept, or the zero of a function. And we can see that point is right at x equals 4. Algebraically, to find the zero of a function, we remember that the definition says the zero of a function are values of x which make the function equal 0. So that's exactly what we do. We make the function equal 0, and we figure out which x's will give us that value. That is, we solve for x. Adding 12 to both sides and dividing both sides by 3. We can see that this matches the answer we got when we solved graphically. Example 2, find the zeros of the function. Here we can see we have a quadratic function. If we made a graph of this using technology, we could find the zeros. So here I've made a graph, and I can see that I have a 0 really close to 1.8, and another one here pretty close to 6.2. And what I can see is that I have to do some approximating here. Notice my graph does cross that x-axis 2 times, and I do get 2 values for zeros. Let's do the same problem algebraically and get some exact answers. I have my function, I've plugged in y as 0, and I'm going to solve for x. Now this is a quadratic, so I'm going to have to use one of my solving techniques. Luckily, in vertex form, we can use the square root method. My first step will be to add 10 to both sides. Then I'll divide off that 2, getting my squared term totally by itself. Now that I have that squared term by itself, I can square root both sides. Remember that when you square root, we get a positive and a negative on this 5. And we square root a square, they cancel out. So on the left side, I have plus or minus the square root of 5. And on the right side, I just have the x minus 4. To get the x by itself, I add the 4 to the other side, giving me a final answer 4 plus or minus the square root of 5. Please note this is an exact answer. We could plug this into our calculator and find an approximate answer. When we have a number like the square root of 5, which can't be simplified nicely, it's because it's an irrational number. Our calculator will round it off so we can get answers like 1.764 and 6.236. But notice these are approximate, and I've used these wavy equal signs to indicate that. The exact answer here has that square root of 5 in it, and that's the way we give that answer. I hope this helped you understand the zeros of a function. Thanks for watching.